good? Good. Hello, everybody. Once again, welcome. My name is Matous. I'm a Chief Cloud Solution Architect in Azure. And today I'm going to talk about serverless integration with Azure Logic Apps. I'm MVP for Azure, and feel free to follow me around on whatever social media you please. That's where I post my updates. But today we are going to talk about what's the value of automation, really, how we can benefit from the integration. That doesn't get to discuss this often as it should be. We're going to get a little intro into the Logic Apps. We're going to talk about how to trigger them, how to run them. And more importantly, we're going to see how we can do all this fancy integration without writing any single line of code. That's what all the people want. I hope so. Is there anyone who really loves coding? Awesome. Well, you guys can watch this too, because even if I'm going to show the demos today how we do it without any code, you can code it your way into that as well. So it's really for everybody. We have some cool demos, hopefully. Praise the demo gods before we start. And we're going to check all about Logic Apps. So first of all, a little bit talk why we doing this thing. Well, my favorite Oracle, Gartner, says that by 2022 we will have 65% of large enterprises heavily integrated within a hybrid cloud. I would say that the number is going to be a lot higher. I personally hope it's going to be a lot higher. And basically, the integration is the main backbone of such an operation, of such integration in the first place. Because how else would you guys move into the cloud and do all the jobs there if your stuff doesn't talk to each other? So today we're going to talk about the glue for the internet, the glue for the public cloud, and how to integrate everything that currently runs and might run in the future in your physical or virtual data centers. Now, if you want to do the integration, we have several options how to do that. We usually try to integrate application to application to exchange information, different systems, identity to HR, CRM, ERP systems, things like that. Sometimes we try to integrate business to business. We want to exchange the data with our partners. We want to exchange the data with our suppliers, providers, whatever. We have more and more SaaS applications spanning across the organizations. So since it's hosted somewhere else, we need to make sure that we exchange information properly with them. And then we have more and more IoT scenarios, all the cool stuff, devices and things like that. We want to get data out of that. We want to get data in there. So with that, we have some challenges. There's a bunch of different APIs, bunch of different interfaces. What service? There's an API. Sometimes we have different data sources. So we might have pretty much unified way how to get the data, but sometimes they come in a structured way, sometimes they come in an unstructured way, sometimes it's different languages, different data operations before we process them. And then we have lots of different things in between, public clouds, private clouds, whatever clouds you want to call them, things like that. So today, we're going to try to find a universal answer for all that, and I hope that's Azure Logic Apps, because Azure Logic Apps are one of the most often forgotten features in Azure. It's a simple workflow-driven service that allows you to create triggers and actions and orchestrate the entire process. There is currently more than 250 connectors, not just Microsoft services, but the others as well. So you can hook it up without any coding with all those features, all those services, all those integrations. I said no code, but if you really want to code, there's an option for that. It's written in JSON. So if you like JSON, if you like structured things, then you can do these things as well. And most importantly, it's got all the buzzwords. It's serverless. There are no VMs, no patching, no operating system management, nothing of the kind that requires to spin this up. And this thing is purely event-driven. So we're going to talk about those events and what actually triggers that in a little bit later. But first of all, just a little bit of an orientation scheme. You can connect all the Azure services, even things like machine learning and cognitive services. You can talk to Office 365. You can talk to Microsoft Graph. You can even talk to old school and legacy applications. You can talk to on-premise applications. It works with SAP, it works with Oracle, it works with all bunch of stuff. So whatever you'd like, you can integrate in there. If you don't see your service in the list, maybe you develop your service yourself. There's another way how you can integrate with that. I'm going to talk about that in a minute. So first of all, how do we run these things? Well, what can trigger that? I said it's event-driven, but even simple scheduling works with these things. So you can have a simple schedule. There's nothing groundbreaking about that. If you today have scheduled services that do something and require VM, this is a great way how to replace them because this thing doesn't require any uptime in a VM. You actually pay per step execution. We will get to the pricing in a bit. So if you have any interval, frequency, something that needs to be triggered by a specific day or time at the day, this thing can work. You can even specify, of course, the complex schedules, such as every second Tuesday in the month, things like that. You can specify minutes, hours, time zones, whatever. Nothing surprising there. You probably would be really surprised if this thing wouldn't be supported. Of course, we don't want to use schedulers all the time. Don't use it for everything. Just use it for non-properly integrated services that cannot really trigger that specific data action on its own. Use it to call for data, use it to schedule reports, use it for operation cleanup, infra cleanup. I'm going to show you how to clean up Azure environment with that, how to give more governance to your Azure environment as well. There's of course an option how to do run once schedules. So if you have any trigger, you can trigger it once per day. You can delay that. You can execute multiple actions. Pretty much the millions of actions can be executed at one time. You name it. We have schedules such as the most common one, such as HTTP request. So it can even act as a bit of an API for you. You can really call it with a webhook. You can call it with notifications. You can call it with lots of things. I will show that in a demo in a minute. We will actually use the HTTP request quite a lot. One of the best triggers that you can possibly find out in the Azure Logic Apps is the Azure Event Grid. That is a separate service, however, nicely integrated with the Logic Apps. So that's kind of service looking forward for changes happening inside Azure and even outside. So if you have any HTTP-based notifications, you have services as event publishers, such as your storage accounts. I want to trigger an action when someone uploads something into a storage account. I want to create an action when somebody deploys a new service in Azure. This is a great governance helper. I want to know every time somebody makes changes to my application. I want to know every time somebody deploys a VM that I want to know about, because maybe it might be expensive at the end of the month for me. And whatever triggers, an event grid can schedule that, and it can help you with the event handling. So event handler can be Logic App, can be other automation methods, such as automation account or even Azure function. We will talk about the differences later on during the slide deck. All right, we have a first demo. Let's praise the demo gods. And let's see how we can actually maintain Azure a little bit more efficiently thanks to Event Grid and Logic Apps. I have a name there, Event Grid for DSC, as a desired state configuration. This is not a classic PowerShell desired state configuration, but it helps us to keep the desired state. So let's say that we have our favorite web application. That's, of course, something super mission critical, because no developer specifies any other application otherwise. It's always mission critical. This one is a simple web application. There's an app service plan. There's a SQL DB. There's a classic Azure website. You know, common things. Now, in our organization, we have a very agile way of developing things. So occasionally, somebody comes by, changes something, and from the Azure perspective, it's kind of hard to say what exactly changed, because from this view, I don't really see. Maybe somebody changed the application service plan. Maybe I'm running on a lot more expensive thing that I actually need, and it might cost me a lot. So what I have here built in the Logic App is a thing that I call Arm Watcher. So if I edit the Logic App, it shows me that The loading takes a while. And there we go. And so, of course, that's demo guts. Come on. There we go. Proper account. Awesome. So basically, in the logic app, in the event grid as our main trigger, I specify that I want to look into the proper resource group, which is that line of business application that I have. And I'm looking for changes. If any change happens, then I want to get notified. If that change is successful, then only then I want to get notified. Because if not, then I don't care. If anyone implemented the changes that didn't go through, then I don't really care about that. Now, I'm going to read the resource. I'm using the connector to Azure Resource Manager here. I'm going to read the resource and see if anything changed. Now, how do I compare these changes? Well, since I'm using infrastructure as code, as one of the talks were here, and I'm using ARM templates, as you've seen in the talks earlier, I exported my infrastructure definition into the storage account. So I have the definition written down, and I just let Logic App to compare the current state to the exported state, and if there's a different configuration, then it's going to notify me. So it's going to send me an email and says that resource with that particular name changed, and this is how it changed. And perhaps this is who did it. So this is the universal way how to trigger the bad guys in your IT organization, doing changes that were not approved or not documented. And this is the way how Logic App helps us to always have documented things. And it's kind of a snitch as well. Right. So if we can drive that into the more sophisticated way, then maybe I don't care about that much of an email notification because I get hundreds of emails every day, and this one doesn't help me. But what I can do is to use these snapshots of the infrastructure in a coded way to be stored through the Logic App in the Cosmos DB. Because it's JSON at the end of the day, so I can this way create universal logger of my infrastructure states without doing any coding, without going anywhere deep and wondering how Cosmos DB actually works. Because I've heard that somewhere it's a cool buzzword, right? Microsoft has been pushing that a lot. But maybe I have no idea where to start and how to push that. So Logic App can actually help me to create this sort of Azure logger and see what infrastructure changes are, how infrastructure changes are made and who actually made them. All right, it's time for another demo, of course, because we don't want to stare at slides all day. So we can check how IT can be done even better with some dev test labs. So here we go, back to the portal. I'm going to close this one. And let's say that we have a company full of developers and consultants. They created a dev test lab. And they have a bunch of VMs in there. You know, and these VMs, they tend to be really expensive if they run all the time. So since it's a test environment, I just want to make sure that these things are getting shut down properly. And of course, I have a timer for that. That's a simple one. I shut them every night. But maybe you know, I want to shut down these applications even when it's not the time. Maybe I want to make sure that they are utilized properly. So if the utilization of the CPU drops, or if the memory utilization drops, or if there's a certain process that doesn't run anymore, I know that my developer left for a smoke break, or he went for lunch, or maybe he's not even working on these things anymore. So I want to make sure that I trigger proper actions for those. So I have the default Azure Monitor monitoring these things and triggering the proper notification. So if such a notification gets triggered, then that one calls a webhook. And my webhook actually ends up in another Logic Apps that I have right here. So if the resources are not utilized properly, then it's going to spin up my Logic App, and it's going to evaluate that, and it's going to create a notification. So before I actually shut this thing down under the developer's arms, and maybe he's just out for a quick coffee, then I'm going to generate a response, and I'm going to ask for who's the owner of this thing, what's the VM name, what's the lab name, and I'm going to generate an email and say, hi, dear developer, perhaps you just went out for a smoke, but you know your VM is not utilized properly. and I'm going to shut it down in 15 minutes. If you disagree, you can click one of these links to skip it or give it 1 more hour or 2 more hours. So this is how the email looked like. It's a very automated way. So basically, the developer receives such an email, and he can postpone the shutdown and say like, hey, I'll be back in a minute. I'm still working on that thing. So in that case, we have a nice evaluation of saying like, hey, okay, no problem. Just wanted to make sure that you utilize our company resources properly, and we don't pay for anything that shouldn't run there. So that was some of the more advanced scenarios. Some of the other triggers can be FTP server, OneDrive, SharePoint, whatever you like. We can trigger stuff based on emails, tweets, team messages. We can, of course, post back into the same channels as well. There's plenty of that. We will even go through some of the things like boring things like calendar. Now, how to make calendar more interesting? We're going to do another demo, this time with Tesla. So let's say that I really want to have better understanding of my meetings. And you know, often I need to go to my meetings and take a car with me. What I need to do after that is do the boring thing and run down the mileage. What I did with in an old school way was that I took a picture of the odometer, then did the math, and submitted into my expenses. What I can do with Tesla and with other smart cars, they actually have API. So there's no direct connector to talk with those APIs, but there's at least the HTTP trigger. So I can get the API. Basically, whenever there's an event in my calendar that says on the way, my Tesla has a special calendar. You can just create that one. Whenever there's a calendar in my event that says on the way, then it gets automatically at the start of the event. It gets the HTTP call. It basically says, get me a mileage. Then I need to parse it because it comes in JSON. So there's a lot of values coming in there because, of course, there's lots of values, such as if the car is parked, what's the state of the battery, and things like that. I don't care about those data. I just need to parse them. So this is an example of data operation. I just create a variable out of that. Because Tesla is an American company, they do everything in miles. So even in the API, it's in miles. So I just need to multiply it by 1.6 something to get kilometers out of that. And the targeted value, I will just send to my email. Now, this logic app is automatically programmed to run once the event is starting and once the event is ending. So it gets me a difference. And it sends it to my inbox. So at the end of the day, I just receive like, hey, when you went to this customer, your initial mileage was this and that. Your trip was this amount of kilometers. And this is what you can put into your expenses. I would put it directly into the expenses, but we are using Concur, and Concur blocks their API to developers who are not registered. So they want to pay you and create like a marketplace for it. If you're using decent service that comes with an API, you can integrate it yourself and maybe create an expense report on your own. If there's somebody working for SAP or for Concur, this is your point for improve. So there we have another demo, and this is another example of integrating services. You can use logic apps even to create your custom Alexa skills. If you have an Alexa at home, that all the thing that the device does is just calls HTTP triggers and talks to different APIs. So you can actually make your Alexa or Google or Cortana, not Siri, she's kind of out of the bunch of those. You can make it to talk to your custom skills. So I'm going to show you how to create your own custom skill using Azure Logic Apps without any single line of code. So we have our Alexa demo in here, and this is just a logic app waiting for to be called. So there's an HTTP request that needs to be triggered. So how do we trigger that? We need to talk to Alexa first. So I open up my Alexa developer console in here. This kind of emulates the physical device that you might have at home. So I I have my custom skill. The skill is named Azure, so I asked Azure to do something for me, and it creates, it talks to these logic apps. So when I go to the test page in here, and this is where demo really gets tricky because now I'm relying on more services to talk to each other. So I can, of course, ask Alexa about basic things. I can say hi. And
hi there.
It's going to say hi there back. Awesome. So it's working. And now we can trigger the Azure skill. So I'm going to just do a little echo request. I can ask Azure to reply.
Hello from Azure.
Cool. So now what it did, it actually triggered the triggered my custom skill. So if I go in here, it basically sent the HTTP request with the payload of JSON, which I parse right here. I have a switch case in here. I have multiple intents, and I have my reply skill. So if I'm calling Azure to reply, then it's just going to generate the HTTP response, and it's going to say hello from Azure back there. Now this is just a simple conversation, right? I can put anything in the plain text, get it back as a HTTP response. What if I want something more complex? Well, you can use any of those 250 connectors in there, and you can put any action there that you like. You can list your CRM items. You can list number of your calendar events. You can list whatever you'd like. You can basically ask about resources in Azure. You can post messages in Teams. You can do whatever you can possibly imagine. So imagine the future where you can basically ask your assistant about how many customers you have in your CRM, what's the state of pipeline, things like that, really. You can even ask them to do something with Azure resources. That's what I like. That's my assistant of the future, except it's today. So I can ask, who made the last deployment and who screwed it up? So who can I blame? I can show that one even on the simple things because every one of us has some VM running somewhere. So what I can do is I can ask Alexa, hey, ask Azure to spin up my favorite VM.
Your favorite VM is starting. Try using containers next time. It's a lot faster.
So Alexa is right about that one. Container would be a lot faster to spin up, but I wanted to show it on what everybody knows on VMs. So if I leave this one, I go in here. There's my favorite VM up here. So I open it up, and let's see if it's starting up. And it's running. So this is how I can use voice with Azure Logic Apps. Thank you. To trigger my infrastructure, I can do the same thing to stop it, of course. You know, you can. This is your kind of like your universal voice assistant that you can trigger and using Logic Apps, and there's no single line of code that you need to do it. So there are some other cool examples of what things that you can use that maybe you things that you wondered about. There are connectors to cognitive services. So what I had in the office as a setup was that I built a little device, like literally a Raspberry Pi. It was running application called Greeting Kiosk that I wrote, and it basically said, everyone, hi, I don't know you, but if you want me to know you, then I can actually say next time I can say hi and your name. So there was an email to opt in. So the process was like, hey, if you want to Greeting Kiosk to know you, you can just take a selfie and send it to this email. Then I had a Logic app at the back end that basically grabbed the emails, only those with attachments, identify if there's a face on it because people might send other pictures. And if there's a face on it, then it grabs the name from that email, stores it in the blob storage, trains the cognitive services behind that, and next time you approach the Greeting Kiosk, it actually say hi and your name. So this is a thing that you can use. Maybe you've been wondering how can you use cognitive services. Maybe you find a tons of examples and different SDKs and things like that. You were a little bit afraid of that. You can actually use these things without any single line of code. You can do it with Azure Logic Apps. I've talked a little bit about the custom connectors. You can access any REST API, any SOAP API. I've showed you how to work with third-party APIs such as Tesla, which is not really well documented at all. If you have your own API that you currently develop in the organization, if you have even the old SOAP API, the thing that you can do is you can actually create your custom connector. You can register your custom connector in there. You can bring your own files. If you have SOAP API, you can bring the WSDL files, and it actually creates the connector for you based on that WSDL file and lets you to add more actions. So anyone can use it without any knowledge of that API. You can just create the action for them. They can use the API without any codes. That's within your organization, within the same subscription. If you would like, and if you own the API, then you're one step from publishing it to the marketplace, and then everyone can use that connector. So if you were wondering how to modernize your old SOAP API and make it a little bit better, then you can bring it to the Logic Apps. You can use sort of REST conversion into that. You can modernize your API like that. Well, of course, that everything costs something. So let's talk about the pricing. Azure Logic Apps are priced per step execution. So if you've seen my demos, there was always a bunch of steps. Each one of those steps is paid. However, it's paid based on if it's a standard connector, enterprise connector, or just a regular action. There's not much of a difference. Usually you pay 0.000 something Norwegian crowns. So basically, if you have an app that runs constantly and it constantly creates some sort of integration, then it's a price of a cup of coffee per month, really. That's the price that you're looking for. This is how much coffee I had to drink to make this presentation. So, so I'm already way above the budget of my Azure Logic Apps with this much of coffee. So do's and don'ts, best practices. Error handling, Logic Apps are great for error handling. Any event handling, really. If any event is happening inside your Azure or outside of it, as long as the event can create a webhook or can notify you by email or can create a file or anything out of that, Azure Logic App is great for that. If you do cycles, things like that, Azure Logic App actually has automated cycle detection, so it creates 4 cycles for you automatically. Helps you really out, helps you to create conditions, helps you to create all that code logic. However, don't do any complex code logic. It doesn't replace that very efficiently. It doesn't replace any complex switch cases, because then you kind of end up with multiple steps in the graphical user interface. It's doable. However, I don't really like that. When it's like more complex condition, I tend to use Azure Function for that. If it's just a one condition, you can write it in whatever language you like. And you can actually call function from that Logic app. So you can just evaluate that function and put back the result. Sometimes I combine Logic apps and functions and automation runbooks based on what's best. So use function for complex coding. Don't try to replace it with the graphical user interface. It's possible, but it's not very comfortable. If you're troubleshooting the Logic app, especially the one driven by Event Grid, try to troubleshoot it not using the graphical user interface, but try to use the REST calls or Postman or things like that. It's much more comfortable. Then you can go into the Logic app and see what actually happened, but it's easier to trigger it from somewhere else. This is something that the product group actively works on, so it's going to get better over time. Now, you might have seen some of the other automation tools. Now, let's talk a little bit about what's the difference. So what's the difference between Logic apps? When you saw the first demo, a bunch of us might go like, hey, that looks like a flow. So Flow is actually a bit younger brother of Azure Logic Apps. It's coming from the same product group. It's coming from the same backend. It's coming from the same thing, really. So the difference between Logic Apps and the Flow is that the Flow is designed for Office 365 and your personal experience running impersonated under your account. Azure Logic Apps are more broad. They can orchestrate things across your organization, the things that you don't necessarily want to have running under your name and things like that. Otherwise, the functionality is almost the same. There are some more stuff in the logic apps than in the flow due to the impersonalization issue. So use flow for your custom things, use logic apps for the more broad spectrum. Functions, serverless thing, good thing for coding. Logic apps are without any code. Automation runbooks for maintaining the hybrid infrastructure, VMs and things like that. That works the great way if you're touching things on-prem. And then there was another thing called scheduler. This one goes away. If you have been using scheduler before in Azure, that one's going to be deprecated. Actually, right now you can't create new schedulers anymore, and the old one's going to go away as well. So we've seen how we can use logic apps, how we can create automation without any code. We've seen what connectors do we have and what they can do. We use almost no code for our actions and learned that it doesn't cost really much. So this is all I got for you. Thank you very much. If you have, thank you.